Okay, so guys, welcome to my YouTube channel, and in this video we're going to be looking at five likely questions and will come out in UTME as regards the organic chemistry aspect. Endeavor to like this video, share this video, and subscribe to my YouTube channel for more educational contents like this. Also, endeavor to share this video to your friends and family, as you would be helping them tremendously by allowing them gain access to this very educative and enlightening video. So let us begin. Now the first question says that which of the following classes of organic compounds undergo reaction with bromine water? Actually, what they aim to test with this question is our knowledge of saturation and unsaturation. Is our knowledge of saturation and unsaturation. And you see, this saturation and unsaturation majorly affects the hydrocarbon series. The hydrocarbon series. And that is what they majorly aim to test in this question. That is what they majorly aim to test in this question. Now they say that which of the following classes of organic compounds undergo reaction with bromine water? Since we have inferred that they are actually in one way or the other asking us for tests for unsaturation, we can knock off three of our options. You see, one of the easiest way to ace OBJ questions is by eliminating options that you feel that are far from the answers. So from our knowledge of this, we can knock out carboxylic acids, we can knock out esters, we can knock out alcohols. Now taking that hydrocarbons are organic compounds that have only carbon and hydrogen. So these are hydrocarbons. Carbons, organic elements that have what? Only carbon and what? And hydrogen. So once you begin to have additional attachments like oxygen, it is no longer what? It is no longer an hydrocarbon. It is no longer an hydrocarbon. Now, what do I mean by saturation and unsaturation? Now, when we are looking at the hydrocarbon series, we have saturated compounds. And we have the unsaturated compounds. We have the unsaturated compounds. Now, the saturated from the name, actually it should give us a kind of hint about what the definition would somewhat be. Now, saturated compounds have only single bonds. For example, something like C to C to C to C, while unsaturated compounds would have what? Double bonds and triple bonds. So something like C to C double bond and C to C triple bond. So basically, unsaturated compounds, examples of unsaturated compounds are alkenes and what? And alkynes. Now, One thing I want you to take note of as pertaining to this question is that, and I would like to probably write it up for emphasis, is that alkenes and alkenes and alkynes would what? Would decolorize bromine water. So the answer to this question is what? Is option B. Is option B. Alkenes would what? Would would undergo what? Reaction with what? With bromine water. It would decolorize bromine water. Now let's move to the second question. It says, what type of reaction takes place between what? C2H4 and the halogens? What type of reactions take place between C2H4 and the halogens? Now, the first thing to do is to actually draw C2H4. The first thing to do is to actually what? Draw C2H4. So let's draw it. C2C. Then we have H, H, H. Oh, let me correct myself. C2H4. We have an H here and we have an H here. And don't forget the principle that carbon needs to have 4 bonds surrounding what? Surrounding it. Carbon needs to have 4 bonds surrounding it. So as to obey that principle, we'll do what? We'll add this here. That means that this compound or this structure is what? It means that it is an alkene. Okay. So which type of reaction would take place between C2H4 and the halogens? Now, how do we go about this? Now, the thing to note is that the principle to actually use is that this compound still has spaces to be filled up. It still has spaces to be what? To be filled up. It is unsaturated. So in order to fill it up, we have to do what? We have to add to what? We have to add to it. So this compound will undergo what? It will undergo substitution. Sorry. It will undergo addition what? Reaction. It will undergo what? Addition reaction, because we have to fill up these spaces. It is unsaturated. So it will undergo what? Addition reaction. So the answer to this question is what? Addition reaction. Because the compound is what? Unsaturated. It needs to be saturated. So it needs to be added to. So it will undergo what? Addition what? Addition reaction. So let's say we had plus Br plus Br2. The compound would become something like this. H to C to C to H. Then we have H, H, then Br, then Br. So we can see that now it will now be what? It has become what? Saturated. Because it has only what? Single bonds all through. So the answer to this question is what? Addition what? Addition reaction. Addition reaction. Now to the third question, it says the hybridization of the carbon atom in ethane is what? Is dash. Now you see, there are some questions that we don't need to do what? We don't need to waste our time on. Now take note of this. For alkanes, the hybridization of the carbon atom is what? sp3. For alkenes, it is what? sp2. And for alkynes, it is what? It is sp. So without wasting our time, we know that ethyne is what? Is an alkyne. So the hybridization of the carbon atom would be what? Would be sp. So the answer is what? The answer is sp. It's as simple as what? It's as simple as that. It's as simple as that. The hybridization would be what? The hybridization would be sp. Now let us go to our final question in this video. Our final question in this video. Now, the IUPAC nomenclature for the compound below is dash. Now, when naming compounds, let me just give us two tips. Let me give us two tips that can help us. The first is trace the longest chain. Number two, give the functional group higher priority than attachments. Now, we would see the application of these two little points that I've given to you. You see, if you effectively follow these small 2 points, naming of organic compounds will not be difficult for you at all. Now, the first thing to do is to trace the longest chain, and actually I can cite two chains here. We have to go for the longest, but I want to show us the two chains I can cite so that we can effectively understand what I'm explaining. Now, the first is this, and the second is this. In fact, it's even probably like 3 self. Another one is like this. But the principle that we are to follow in IUPAC nomenclature is this. Is to do what? Is to trace what? To trace the longest chain. So for this question, we'll trace the longest chain. And that is by counting the number of what? The number of carbon atoms present in each chain. Now let us go. With this one, we have 1, 2, 3, 4, 5. Wow. This one we have 1, 2, 3, 4, and 5. This one we have 1, 2, 3, 4, and 5. So we can actually go with this one or this one. Why this one here is what? This one here is what? Is out of it. This one here is out of it. So let me erase it so that we can, so that we will not be confused. Good. Now, the next step in naming is to give the functional group the lowest number possible, and this is the functional group. They give the functional group the lowest number possible. So if I name from here 1, 2, and 3, that is 3. Wow. If I name from here 1, 2, and 3, that is 3. Okay. If I name from here 1, 2, and 3, so that means that but if I name from here, I come like this, it will give me 1 and 2. So automatically, the one I am to follow is the one that comes from this side, so that this functional group can have what? Can have the lowest what? The lowest number possible. So following that, we would see that the parent name is what? 1, 2, 3, 4, and 5. Pent 2 in. Now, the next is now looking out for what? Looking out for the attachments. Now, if you are following this direction, like I've said, we'll see that the only attachment that we have is this what? Is this CH3. So we just count from here. Oh, 1, 2, 3, 4. Wow. So that is 4 methyl pent 2 in. So the name of this compound is what? 4 methyl pent 2 in. 4 methyl pent 2 in. Now let us go for our last question. Our final question. Now it says an example of a compound that can catenate is what? Is dash. Now, without wasting our time, we should take note of this. Now, these are the things that I want you to actually take note of. Examples of compounds that can catenate. I don't really like this word somewhat. Examples of compounds that can catenate is we have boron, hydrogen, phosphorus, carbon, sulfur, and silicon. So these are examples of compounds that can do what? That can catenate. Now, what is catenation? Ability to form long chains. Catenation is the ability of a compound to form long chains by covalently bonding with itself. So, so the catenation is the ability of a compound to form long chains by what? By covalently bonding with itself. So because of catenation, carbon can bond with another carbon atom. It can bond with another carbon atom. It can bond with another carbon atom. So this is exactly what we are calling what? Catenation. And it is one of the reasons why carbon form the bedrock for other organic compounds or other organic families. This is one of the reasons why it what forms like the bedrock for other organic families. So the answer for this question would be what? Would be carbon. Carbon is an example of a compound that can what? That can catenate. So this is our last question. Endeavor to if you have any other questions, you can ask in the comment section, and endeavor to like this video, share this video, and subscribe to my YouTube channel for more contents like this. Till we meet another time, I am Medic Ozone. Bye bye.